Hello, my dear friends. Welcome back. It's raining very heavily, isn't it, today? But anyway, we can continue with our classes. I hope you can all hear me. Today we'll be just solving the exercises, so I guess you can follow with me. But before we really begin our classes, let's wait for some more of our friends to join us. So in the meantime, I have some trivia questions for you. Certain questions which generally gets missed out, isn't it? So you can try and guess if you know the answers. So in the meantime, we'll start in maybe just a couple of minutes. So in the meantime, I have written down some trivia questions for you. You can just have a look at it. Let me see who else have joined us today evening. Sophia, Mona, Cynthia, Priyanshu, Kali, Olensa, Halata, Kunsanga, Lumula, as always, Neha, as always, Cynthia, Luno, the Tegrino, as always, Avila, Murmina, Tromina, Mari, Yosimina, Mount, Kaba, and so on, okay. Insotila, Lance, Montgomery, alright, Atukere, it's me, okay, Susila, Achang, okay, finally I got your name, Achang. You have always been very regular. It's Nora, Lamina, Akila, Rosin, Asila, Captain Born, Sashibon, Lagibol. A very good evening to each and every one of you. Some of you have joined, I guess, are somewhat new to me, but most of you are the same family members. So, welcome back once again. It's been a long time, isn't it? It's almost over a week. I guess you can all hear me clearly. Can you all hear me clearly, my dear students? Good evening. Can you all hear me, my dear students? Today most of you joined at the right time, so we can begin very early and then we can just move on. So let me just one more minute. Can you? I guess all of you can hear me very clearly, I guess. Of course, I'm screaming at the top of my voice because it's raining very heavily here too. Alright, it's good to know that you can hear me. Alright, so before we really begin, just wait for a few seconds now. So, did you get the answers here? Can you, I hope I'm not shouting too much. I hope I'm not screaming too much because it's kind of raining heavily here. So I guess your ears are all fine. I guess I hope I am not screaming too much. Oh, my haircut. Thank you for the haircut. Arjun. Thank you so much. Finally, at least someone recognized my haircut. Alright then. So welcome back once again, my dear students. The big exercise is already done. Continuity is already done. I've provided some videos to build up to this exercise 5.3. I believe you have all watched those videos. So we are going to solve how many questions? 15 questions from exercise 5.3. So we'll be solving 15 questions. Anyway, any guesses for the answers? First one. One of the uses of differential calculus is describing how steeply a curve is rising or falling. This is measured by a straight line which touches the curve at exactly one point. What is the name for such a line? Any answers for that? Alright, I'll just give you the answer for this. This will be called a tangent. As we all know. Yeah, exactly. In the terms, exactly, yes, a tangent. Good. What about the second one? I guess this is done. I'll rub it off now. Second one. Who is widely considered to be the father of calculus? Any guesses again? Come on. So, in the meantime, as you guess, my dear friends, if you still haven't subscribed, please subscribe. Give me a like if you still haven't liked the video. If you like the video. Any guesses for this also? Who is widely considered to be the father of calculus? Yeah, good evening, Sangeeta. I guess no answers for this. Of course, maybe since this is slightly controversial, so I guess you are also slightly reserved in giving me the answer, I guess, because this is slightly still controversial. There is no definite, as we can say, father of calculus, but there are two persons who are actually credited, given the credit. Yeah, exactly. One of them is what exactly Lono has stated, but there are two persons. There's one more person. Of course, Isaac Newton is there. And there is one more person who's also given the credit for the topic calculus. Of course, this is still under controversy, exactly, we don't have any specific, but Newton, of course, is widely considered, but there's one more again, both of them actually are widely considered. I hope I've spelled it correctly. Gottfried Leibniz. Gottfried Leibniz. So this is another person. Actually, both are doing this calculus in late 17th century. So both of them say that he was the first one, I was the first one. So this is still under a controversy. Of course, Newton's it is said that Newton's works were published late. Gottfried Leibniz, he published it early. So, but still there is a controversy. So in general, widely actually, both of them are actually considered as widely considered. There are many more scientists who are given the credit, but mathematicians I would rather say. But these two are given, the widely given the credit for the. Okay, all right. So I guess you have learned something. Let's get to the exercises. So I hope you have your textbook and paper. Get ready. I can't hear myself. Rain or shine, learning has to continue. So it's good to see that all of you have come. More and more are joining day by day, so I'm feeling very privileged. I'm getting really motivated by all of you. I know these are difficult times, but it's good to see that you have come out from your comfort zone and joined us. So that is really very encouraging. Thank you for joining us. All right, thank you, and do continue to join the live classes because days are running out. June is about to end. All right, so before we start this exercise, I've given you the build-up to this exercise. What were the topics? Implicit functions, which was done recently. I'll provide you the link if you haven't gone through. Then using trigonometric transformations, and then inverse trigonometric functions. So I've done exercises on that, so I'll quickly solve the exercise. So pick up your pen and paper, let's begin. So this is an implicit function, as you can clearly see. So we'll differentiate both sides with respect to x. I'm not going to write that, okay? We're just going to, okay, first question. So First question, so I'm going to write everything in detail, but as we proceed, we're going to skip some of the basic steps, okay? So derivative of 2 constant dx with x, 3 dy by dx, implicit functions, I hope you remember that, so I'm not going to waste much time explaining the stuff once again. Derivative of sin x is cos x. X with respect to x is 2, this is 3, of course dy by dx shall remain as from the concept of implicit functions. So our job is now to solve for dy by dx. Simple question, 2 mark, maybe. So first one is cos x minus 2 divided by 3. Let's go to the second one, 2x plus 3y. X plus 3y equal to sine y. 2x plus, almost the same like the first question, the only difference is this is y. So this part will remain the same. If you remember, yes, chain rule concept shall come. So here derivative of sine y, yes, is going to be cos of y, but with the concept of chain rule y by x will continue, dy by dx. So here I'm going to change the equation a bit. I'm just going to write it 2 because this is already done. dx with respect to x is 1, isn't it? Of course, if you want the textbook answer, this negative sign you can bring it down, so that will be 2. So minus minus, so that's going to be cos of y minus 3. If you want to match your answer with the textbook, otherwise this is also enough. A, derivative of x with respect to x, that's 1. B, constant, arbitrary constant. Y squared, that will be 2y. Of course, chain rule again, dy by dx. Derivative of cos x, if we assume, minus. But again, derivative dy by dx. Chain rule. Don't forget this, okay? This is one place where many, they just jump over it. Now I'll be solving for dy by dx. So job done. Simple basic differentiation only. So let's wind up this topic today, so that we can move on to the bigger topics. Especially in exercise, we have like 5 point, this is 3, 5.4, 5.5. 5.5 is a big topic, logarithmic differentiation. So there, of course, I guess we will need at least 2 to 3 videos to complete the exercises. Okay? You can continue, you can just continue. Don't worry, I will be solving all the questions. So those who can, you just continue and verify. Okay, let's do it together. Let's do it together. Go. Together. I hope all of you are doing your studies well, my dear students. As I always tell you, things are not easy for anyone. It's not easy for me also. I can understand your problem also. But we have to make adjustments. There is no other way. Okay. The world has come to this stage, so we can't help it. We can't blame anyone also. Now, what is derivative of x into y? Remember product rule. Again, do not forget your concepts. Product rule. So, derivative of xy will be what? X into dy by dx plus y into, I'm just going to write full, dx by dx. Plus, okay, no problem. Few problems, I can write all the steps. Dx. Derivative of tan x is, of course, sec square x, comma, plus derivative of y with respect to x. So I'll start solving for dy by dx. Derivative of y square, just recently we have done 2y, dy by dx. I'll be needing that, so I'll just bring this on this side, dy by dx, sec square x. So now dy by dx common for all the elements. So we'll have x plus 2y minus 1 dy by dx. That's going to be equal to sec square x, this y value in that side for solving, minus 1. So dy by dx so you can see basic differentiation only. Topics, please give time to this, okay? And remember, as I tell you always in mathematics, especially class 12 mathematics, is good, your integration also will be good. And if your differentiation and integration are both good, then your physics also will be good. So that's how it is always connected. But the main part is this, because they give us, I think, almost around about 50% of the marks from the syllabus. So this calculus portion becomes very important. Yes, it's not difficult, absolutely not. But it's somewhat similar to practice here. So don't skip for a day also. So fine. Derivative of x squared is 2x, there is no remainder left, no chain rule, isn't it? But just now we did xy, so that there of course we'll have to use the concept of chain rule. So x into dy by dx plus y into dx with respect to x, that is 1. So I think it's okay if we don't write anymore, right? Okay. Derivative of y square is 2y. So chain rule, okay, rain is stopping, so I'll have to now scream less. 100 is a constant value, so that will be 0. So now let's solve for dy by dx. I'm going to do directly, class 12 standard, so I think all of you are good enough. You are good enough. It's just that you are lazy sometimes, nah? Yes or no? Don't be lazy. I would also like to thank many of you, okay, for giving me your love and support in whatever I'm trying to do for you. I always say that, I'm going to continue saying that, because without you, it would always be empty. So, like, thank you once again, okay, for supporting me in whatever I'm trying to do for you. I get motivated. You never fail to motivate me. So yeah, I really appreciate that. And it motivates me, to do more. It motivates me to do more for you. So, thank you so much. So 5 questions done, 10 questions left. So let's go to number 6. Solutions, of course, you can get it from anywhere, but it's not about simply getting the solution. It's about like sitting on the table, doing things for yourself, trying to do things on your own, work out, get confused. I always say, if you get confused when you're trying to learn, those are good signs. That means you're trying to learn. Next day you will wake up a better person. At least sometimes shock your brain. Give it some exercise. Okay, what is this guy doing now? All of a sudden studying. Again, x squared into y, again chain rule. Let's not forget. So x squared into dy by dx. Be steady, okay? Into y, derivative of x squared with respect to x, plus again here also chain rule. So that's x into derivative of y squared with respect to x plus y squared. Okay, I'll just write derivative of x with respect to x plus derivative of y cubed, that's 3y squared. Simple differentiation. Of course, chain rule dy by dx, because we are differentiating it with respect to x. As I told in the previous video, the variables can be different, so you have to be careful there. Sometimes if you're doing it with respect to y, you're differentiating a function of y with respect to y, then the chain rule concept doesn't come. It's simply like differentiating x cubed with respect to x. There the variable remains same. The 81 is a constant, so that's going to be 0. These are long, lengthy questions. Anyway, don't miss out, okay, y squared, 2y, derivative y into x, y by x, I mean, chain rule. Of course, this is only y squared because x with respect to x is 1. Now let's start solving for dy by dx. So I'm going to do it directly. X squared, this is done, plus 2xy plus 3y squared, common, dy upon dx equal to, all these terms will now go to the other side, minus 3x squared minus 2xy minus y squared. dy by dx is equal to, I'll take minus common there, minus 3x squared plus 2xy plus y squared upon x squared plus 2xy plus 3y squared. So as I've repeatedly been telling you, these are simple differentiation only, not very difficult. But yes, you have to be careful with the chain function, chain rule function. Okay? You can note it down. If you have any requests to be made, or you want to tell me, if you want to request certain things, you can let me know in the comment section below, because now these are live classes, so you're free to interact with me positively, of course. I know you are all good people, so if you have any, requests, you can let me know. Okay? Done? Let's move on to the next question then, if it's done. So 7 finished. Okay. No, 7 to be done. Sine square y plus cos xy equal to maybe k. If you wish, I can rewrite this equation for you. Chain rule we have already done. Anyway, once again, xy, cos xy means cos x into y, okay? It's not cos x into y, it's written as xy. Okay? So now let's differentiate. So sine square, so again chain rule, what was the differentiation of x square? The differentiation of x square is 2x, but this is not x, so 2 sine y, if you remember, chain rule. Then of course we'll have to continue with the differentiation of sine y, not chain rule concept. The chain rule becomes very important here. Differentiation of cos xy is differentiation of cos x is minus sine x, minus sine xy, but chain rule again, we have to differentiate the xy. So maybe I'll just do something like this, because this is within this. Of course, derivative of k that will be considered as a constant, 0. So 2 sine y, what is the derivative of sine y? Cos y. But don't forget, my dear children, this is y with respect to x minus sine of xy. Now derivative of x, again, brackets are very important. Your parents give you food to your brother and they just tell you, tonight you don't take, let your brother take. Will you be happy or what? No, no. So that's why this product, whatever derivative we get, is multiplied with sine of xy. So don't leave this out. Alright, this is a whole multiple, so be careful there. Don't be partial. I'm not doing all the steps now because it's x into derivative of y with respect to x plus y into derivative of x with respect to x, that's already 1. Trigonometry. 3 row. 2 sine y cos y. What was the formula? 2 sine theta cos theta, sine 2 theta. Sine 2 theta. dy by dx. Now I'll just multiply. Minus, better to write this in the beginning so that there is no confusion. X into sine xy dy by dx. Minus into plus, that's minus y into sine of xy equal to 0. So now let's solve for dy by dx. So that's sine of 2y minus x sine xy dy by dx plus of y into sine xy. So dy by respect to x is y of sine xy. If you wish, you can add the bracket. Otherwise, if you don't wish, no problem. I'm just using this bracket so that you're not confused with any values. Okay? Those are finished. You can prepare yourself for the next question. Alright, half an hour more. Time out, time out, time out. Water, water, water. Time to drink some water. So you can write down the question for the next one. Or you can have a sip of water also. Alright, I'm back. I forgot to keep water today, so I just drank the old water that was left. That's 7, but there's still more. 8. Sine square x plus cos square y equals to 1. So now let's do directly. Okay, chalo. So differentiation of, ready? We're gonna do now directly. We're gonna do now directly. Really? No. It's okay, I'll give you the steps. Not a big deal. I have all the time for you people, so no problem. Derivative of 1 of course is 0, so at least let me not write down 1. Twice of sine x. We still have to continue with derivative of sine x because chain rule to chain rule, nobody can change it. Minus sine y, but this one is y with respect to x. Let's not. Every single question I'm reminding you about this, okay? Y with respect to x, implicit functions. Plus into minus, minus. So this is again minus of sine 2y dy upon dx equal to minus of sine 2x. All the people out there with me? I hope some of you have not fallen asleep. I guess you're watching football, Euro, because the season is now. Almost at the end of the first round, isn't it? So minus I'll cancel. So what is your second country that you're supporting? So dy by dx is sine 2x by sine 2y. Finished. Rubbing off. I hope some of you are not wearing the jersey and sitting there. Why is everybody so silent today? Knock knock. Anybody home? What, Vincent? Just mind your own business. You're here to solve exercise. Chalo na, solve na, solve na. Are, I also want to interact though. Okay, nobody is in the mood. Okay, someone is already in the mood. Alright, good to know that you're all there. For once, I thought that all of you had gone missing. Because when you keep quiet and silent, it becomes like, what happened? Acham already said he's supporting Belgium. Cool with that? Actually, I support. Which country do I support? Germany has always been my favorite team. Germany. But since the last World Cup now, very disappointing. Actually, football, none of the teams that I support are really actually winning. Maybe not good in supporting, I guess. So Germany, of course, has always been my favorite team. But yeah, honestly, yes, it's a very tough group. So we still do not know which country is really going to advance into the next stage. But Portugal again, I've always been fond of Portugal also. You know, they are like dark horses every time. So Portugal also not bad, okay. But of course France is a very good team, but I don't know what happened this time. They are really not playing as expected because we look at their players, really tough and really good. And Belgium, of course, that is also a good team. So yeah, I think I better start supporting students only instead of football teams, because the other club that I usually have been a big fan of, the Arsenal, that is also not not doing very well these days. So I think I will just stick to supporting students only. Maybe I'm just good at that only. All right. Anyway, fine then. We'll talk about that again after some time. So up to question number 8, that was about implicit functions. That's what I was telling you. You know, this exercise was a combination of 3 different topics. Now this one, if you remember, that was this video was again given to you, differentiation using trigonometric transformations as well as inverse trigonometric functions. So we're going to need that concept now here. Okay, using trigonometric substitutions. I believe all of you have watched it. Please, if you haven't, after this, immediately please go and watch. I've solved many extra questions. Not too many. You might feel bored, so that's why I gave around about 4 or 5 questions only. But you can just check those exercises. That's really going to be helpful. That's why I'm giving you something extra. Okay, so you can just kindly go through those videos. So now we'll do that. So there's nothing much to discuss much because it's already done. So after this, you can just go back and watch that previous video. But briefly, substitution. So for this, as I said in the previous video, as I said, you have to know your trigonometric formulas very well enough. So if you still haven't, again, get a copy. What did I tell you in that video? Those who are listening, those who watched, I told you that put down a list of all the trigonometric formulas. Okay, put down a list or write down all the list of trigonometric formulas. If you need it, you can let me know. I'll give it to you also. And very soon, maybe I'll be posting it in the community page or the Instagram page also. And you can note it down and paste it in different paste it in your room, and when you're practicing, don't hide it from yourself. Okay, don't fool yourself. You just keep it in front of your table, places where you can see, so whenever you have any doubts, you look at those formulas and then do. That's the way to practice. Many will tell you like memorize it, never open it, close it. No, that's not the way we usually study. Alright, so of course we have different styles of studies, but that's not the usual way. No, we practice only, we become better. Okay, memorization, no, that doesn't help. So this one is a formula that is of course familiar to me, that is, I'll start substituting that x equal to tan theta. So that would imply by inverse trigonometric transformations, theta would be equal to tan inverse x. I've shown to you in the video, so let me not talk about that. I've run about some more questions to solve. So now when I substitute substitute for x, I have sine inverse twice of tan theta 1 plus tan square theta. So that is sine inverse. This formula, as I say, it's familiar to me, so that's why I've used tan theta, because this formula is sine of 2 theta. So in that case, y becomes sine inverse sine, that's 1 inverse trigonometric functions, we have 2 theta. So y becomes twice into theta value. Now we can use this substitution, that is tan inverse of x. That's why I did all those 2-3 videos just for this one exercise. So now, then we can differentiate now. dy by, so differentiation starts here only now. So far we were, see, that's the advantage, as I told in the previous videos also. What, man, this guy's always talking of previous video, talk sometimes here also. Alright. See, just to differentiate this function directly, you can give it a try. It's not going to be that simple, okay, just to differentiate this. I'm not saying that simple. So that's why we take the help of trigonometric functions and simplify the equation first. Simplify the function first. So you can see now it's perfectly simplified. So because once we go for differentiation now, it's very simple. That is 2 into differentiation of tan inverse x is 1 by 1 plus x square. Bus. So differentiation just one step. 2 by 1 plus x square. So differentiation just one step only. Alright, okay, let's try another question again, number 10. So almost at the end, not completely, but yeah, we are almost halfway, more than halfway now. Question number 10. Y is equal to tan inverse. Actually, to be honest, very honestly, I'm telling you, I was actually very exhausted today because I had a lot of work at home. Of course, these are just about domain and range, so I will not be concerned about this that much as of now. It just gives us a license to proceed, but this one so actually I was like very exhausted, okay, today, So, but when you come up in such good numbers and then you are more anticipating the classes and all, my exhaustion has just disappeared, like just interacting with you. This is what I love. This is something that I really, love doing. And then the support that I receive from not all, but chalega, no problem. But so many of you, so many of you, the support that I receive, you see my exhaustion has just gone, and then I'm enjoying trying to, just give you something that I know. Just give you a little bit that I know. I don't know much, I just know a little bit, but it's good to share. Education and learning is just about sharing, Okay, now share this also, sir. Okay, alright, I'm going to share this also. This is also a trigonometric formula again. Last year one problem was that your syllabus was reduced, so that's why you'll be having some problems now. So, but anyway, there's still time, we can pick it up again. So here what I'll substitute is again x equal to tan theta. So that is again theta equal to tan inverse x, because the thing is this, that's why you need to know your trigonometric formulas here. If you don't know it, then this topic will be like or trying to learn foreign language. So for some of you, you might be assuming, for some of you, it might seem that I'm talking in a very different language, Sanskrit or some other language. So most probably that is because the functions are not very clear to you. You're still not familiar with the trigonometric formulas. That's the reason. So y equal to tan inverse. As I said, x. If I just substitute that, then tan cube tan square. I know that this is the formula for tan of 3 theta. Multiple angle formula. So tan inverse tan, done. So you can see that the function is again simplified. So then y, I'm just going to write like this. So y is simply again 3 tan inverse x. So if you know your functions, very easy. Okay, dy by dx is equal to 3 into what is derivative of tan inverse x? Again, just now we have done 1 by 1 plus x squared. So it's as simple as that. Now, this is also again same. This is question number 11. So here also the thing is that I'll be just substituting this formula. I think I gave you the formula in the previous video for this one. So then here also y is inverse of 1 minus tan square theta by 1 plus tan square theta. Now does this formula seem to be familiar to you again? If you have the notes, you can check. I'll just write here. Again, yes, this is cos 2 theta. I think I gave you the formula for this in the last class. So y again is equal to 2 theta. So I guess you are getting my point now. It's about just knowing your formulas. You should know exactly what to substitute. Bus. Job done. So as you can see, differentiation is not just substitute the right function. Done. But you have to identify. How can you identify? And there's no particular shortcut to that. It's about practice, as I see. You just get stuck to your mind, brain, and then it just flows. Alright, it just flows. Some of you must be wondering how we do all this. Come on, man. We have been teaching for so many years now, more than almost 15 years. So that's practice. Not that we were born like this. Absolutely not. Okay, we were not born good. Actually, as a student, I feel I could have done a lot more. I was horrible. But with practice, with practice and especially teaching for more than almost 15 years, we're able to do things. Okay, so don't be surprised. You practice, I'm sure you will be able to do it. Take my word for granted. I'm sure you will be better than us. But you need to do it. Okay, you need not just dream. Not dream. You need to do it. Wake up, do it. Okay, 12. Y is equal to sine inverse. This time 1 minus x square 1 plus x square. So we don't have any special functions for this, but you see how we will manipulate, how we will change things. Same function I'm going to substitute, let x equal to tan theta. So that would imply, of course, theta equal to tan inverse x. Yeah, I know, sir. I'm not going to be getting cos, but look, have a look. Sine inverse 1 minus tan square theta by 1 plus tan square theta. So that's of course sine inverse cos 2 theta. Yes, I know what you're trying to tell me. It's cos theta. So sine inverse and cos, how am I supposed to solve? Come on, man. You know what? Class 10, complementary angles, trigonometric functions, complementary angles, you remember? What was that? We know that, what was it? Sine of pi by 2 minus theta. Class 11 also we have learned this. Is cos theta. We'll take the help of this function. So that means cos theta can be written as sine of 90 minus theta. So that means I can write this as sine of 90 minus theta. Of course, my angle here is 2 theta. Again, don't make a mess out of that. So sine inverse sine, you see. So y is pi by 2 minus 2 theta. Simple as that. So now let's differentiate. So theta is tan inverse x. Done. I'm rubbing this part. Oh yeah. Okay. So y is equal to pi by 2 minus 2 times of tan inverse x. So now let's differentiate. So dy by dx. Differentiation of pi by 2 is 0, as we all know. Minus twice of, again, differentiation of tan inverse x is 1 by 1 plus x squared. So the ultimate value minus 2 by 1 plus x squared. So guess what? Same. Trigonometry. Trigonometry. There's no escaping from it. Oh yeah. Chalo. 13. Chalo. Almost 13, 14, 15. Just 3 more questions. Be with me. After that, we have a small exercise. Don't worry, I'm not going to be doing it today. But after this, we have a small exercise. So that's not going to take much time. After that, only we have the big one. Look at it. Taking the help of logarithmic functions and differentiating. Yeah, tan theta is our new favorite trigonometric function. So you start being friendly with tan theta, okay? It's really going to help you. But honestly, as class 12, most of the functions that, as per my experience, also I have seen, like most of the functions are, with this tan theta only. And again, you just have to use some other functions. That's when, what do we say, we get stuck. So do not ignore, but yeah, be more friendly with tan theta. So here also again we are going to use tan theta only. This is similar to that previous question, number 12. Just the other way around. They could have given some other questions, but anyway, let's just finish this for formality. Ai, theta. So now cos inverse, again the same stuff, complementary angles. So sine theta also can be written as cos of 90 minus theta. So it's basically the same thing. So cos inverse cos, I'll just write here, continue. So pi by 2 minus 2 theta. So y would be simply again pi by 2 minus twice of tan inverse x. Don't marry trigonometry now, you're still too young to choose your life partner. Oh, find the perfect one. Trigonometry will just give you headache only. Marry someone beautiful. Beautiful in heart, not beautiful from inside. Okay, let me just not start a love class here. Maths, calculus. Hey, such a complicated topic. Why are we discussing about Pleasures of life is. I think this one you can differentiate, isn't it? I'll just leave it there. Alright, we can just complete it. Okay, now that one to find now. This was number 13. So I guess you can complete this, isn't it? After that, you differentiate. Okay, chalo, क्या है खत्म कर देगा dy by dx is equal to 0 minus twice into 1 by 1 plus x square, so minus 2 by 1 plus x square. Happy now? All right, last second question. This one too, okay, wrapping up. 14. Chop, where is the chop? Okay, 14. Okay, finally, slightly interesting question. So now, we'll, trigonometry, I mean tan function, okay, let's give it a break. That's why all of a sudden you get some functions which, we are surprised all of a sudden, and then we have to use. So what can we use here now? What function can we use here? Think substitution. Remember, from inverse trigonometric function, sine inverse of sine theta only is like theta. Sine inverse sine is 1. There should not be anything. No minus, no plus. It's function to function. Okay, function to function. So I have to convert this, substitute, and you don't get a sine function here. Remember one formula? Once upon a time. Remember this formula? 2 sine theta cos theta equal to sine 2 theta? Yeah, can we try to do that here? So if we try to do that, possible now? Yes. What substitution should you make? Okay, let x equal to sine theta. So then that would imply theta equal to sine inverse x. So now y will become sine inverse twice of sine theta root over of 1 minus sine square theta. So that would be sine inverse 2 sine theta. This is what? What is this? Class 12. Come on, somebody tell me the answer directly. What will be root over of 1 minus sine square theta? Come on, you can do it. Janona. Root over 1 minus sine square theta. Come on, directly. I don't want to do all the steps from class 12. Come on, please. I'm waiting. Somebody. Root over 1 minus sine square theta. Come on. I'm waiting. This is square root of 1 minus sine square theta. Yeah, cos square theta, but again square root. So is it okay if I just write, cos theta? I think that's fine. Class 12 standard. Of course, it's cos square theta, but again square root is there, so it's cos theta. That's fine, I guess. So sine inverse of sine 2 theta. So y is ultimately 2 theta. Y is finally a break from tan function. So we have sine inverse x. So then that would imply derivative of y with respect to x is 2 into what is sine inverse of x? Don't tell me that, sir. Trigonometry has got me so badly. Tan function has got me so badly that I forgot about sine theta. Who cares about sine inverse x? No, we have to care. So then that's like 2 by root over of 1 minus x squared. So, last question. Okay, I'll give you a hint. this will be another break from tan function. So now, since this is the last question, you tell me. I hope you have your formula sheet spread all around you. So now you tell me what function should I use. I'll give you a hint. First hint is no tan function. Alright, no tan function. We'll be taking a break from tan function. Second hint is, what is the function there? Sec inverse. So if I can somehow get this as 1 by cos, then 1 by cos is sec. So my concept would be to even get cos here. Cos theta or whatever be it. Cos. So what should I substitute? You got my point? First hint, as I said, no tan function. Second hint is, if I can somehow get a cos function here with the right substitution, this one, denominator. So 1 by cos would be sec, so that won't be that difficult. So tell me which should I substitute. If you still haven't liked the video, give me a like, please. Some of you must be wondering. You're asking me so many questions to be done. I'm still waiting for the answer. I'm just saying in the meantime, some of you just... somebody did. Yes, give me the answer. I'm actually waiting for the answer, okay? Last question. Come on. Take out your formulas. Remember, I need cos here in the denominator. If I can just convert that to cos function. Still waiting for me. So yeah, x we can substitute as, I'm waiting for you. I'm waiting for you. Okay, tonight what matches do we have? In the meantime, some of your friends are trying to find out the formulas and all. What matches do we have? Cos theta, exactly, Asun. Yeah, cos theta. She already gave me the answer before we could really decide on what matches we have today. Because we know the formula, isn't it? Cos 2 theta is twice of cos square theta minus 1. So we'll be taking the help of this. That's why you know your formulas well enough. Alright, yeah, thank you. Many of you got the concept correct. Anyway, what matches do we have tonight? Actually, teaching and all, I've lost track of, sometimes I lose track. I cannot watch all the matches even if I wish. Because I get so tired. By 12:30, I'm almost done for the day. There are 4 at the same time. Yeah, of course, that's the last match. So, last match of every pool. So, no team should be taking advantage, no? So, I guess that's the reason why they're having the same match. I mean, the match at the same time, no? So, I guess this is clear. 1 by 2 cos square theta minus 1. So, 1 by cos 2 theta, that is equal to, as I said, sec 2 theta. Any big matches today? Like big teams playing? Worth watching. I should not be missing or something like that. Yes? Any matches today I should not be missing, like big teams playing, crunch matches? Yeah, who is into football? So we have come here to study and then you're talking about football. Go and watch football. Last question, so I'm also going and watching football, definitely. 2 into... Chalo, let's finish. Derivative of cos inverse x minus 1 by root over minus x square is equal to minus 2 by root over of 1 minus x square. Ho gaya na? Finish. Pass. Khatam. Exercise 5.3. End of the story. Only on Thursday. Okay. All right then. All right then. Thank you so much for joining in and being a part of our classes today. It was more fun for me because there were more of you. So I hope you encourage also to come be a part of it so that they are also not left out. Of course, we cannot pull them, but maybe try to encourage them and join so that none of your friends are left out. Okay, so all right then, thank you so much. For the next class, let's see, maybe tomorrow we can have a short class. All right, so we'll decide and we'll let you know. All right, so fine then. Thank you each and every one of you. A very good night to all of you. Good night, yeah, those who are watching now. Okay. Okay, all right then. Yeah. What do we call it? Thank you so much.